Science education, fitness too. Molecular Mom's got it all for you.
Hi everyone, thanks for tuning in for our episode of Molecular Mom. So you've probably heard of a friend or a family member that has claimed that, oh, I got pregnant when I was on birth control. Most people kind of eye roll, oh yeah, sure, you probably weren't actually on birth control, or you weren't taking it as you should. You were skipping doses or not taking it at the right hour each day. But there's a new study that suggests that your genes could actually be a cause of birth control failure. More than 60% of women of reproductive age are currently using a contraceptive method. Hormonal contraceptives account for the majority of those that are using a contraceptive method, with sterilization typically being the second most common. And the failure rate of hormonal contraceptives is anywhere from 0.2 to 9%, depending on perfect use to imperfect use, typical use. Types of hormonal contraceptives are the pill, the patch, the implant, injection, a vaginal ring, or maybe an IUD. There are some forms of IUDs that are hormonal. So when you ingest a hormonal form of a contraceptive, or it's injected, your body has to process that. And many genes are involved in hormone metabolism, regulation, and function. The liver is the main organ that's responsible for the metabolism of many ingested medications, including hormonal contraceptives. And the cytochrome P450 enzymes metabolize over 50% of all drugs that are cleared by this system, and including hormonal contraceptives are cleared by the cytochrome P450 enzymes. So medication response testing is something that I reviewed on my last Molecular Mom episode. Pharmacogenetics testing is a medication response testing looking at genetic variants, looking at your DNA to see what changes are there. And it's an important tool in medicine for personalized medicine. So it examines changes in your genes that encode enzymes that participate in drug metabolism, or clearance or transportation of those drugs into and out of the cells. And so pharmacogenetics aids in the therapeutic efficacy and toxicity avoidance issues that you have with various medications. So is there medication response testing for birth control? Well, not to my knowledge right now. It's not currently offered for guidance for what types of hormonal contraceptives will be most effective for a given individual. Well, why not? Why don't we have this testing yet? We have pharmacogenetics testing for other drugs such as warfarin or Xanax and some other antidepressants. Why not for hormonal contraceptives? Well, it's because that there's a lack of case-controlled clinical studies assessing if genetic changes are regulating hormonal birth control efficacy. We just don't have that information right now. But you would think it's a good hypothesis that since there are enzymes that metabolize hormonal contraceptives, that if you mutate or change some of these genes that are responsible for metabolism of these contraceptives, that you could impact their efficacy. And there actually was a recent study, I believe it was in April, by a group out of the University of Colorado. And they enrolled 350 healthy reproductive age women that had the inetogestrel implants. So this particular drug, hormonal contraceptive drug, is an implant, and it primarily inhibits fertility by inhibiting luteinizing hormone, which is required for ovulation. So the drug itself causes suppression of ovulation. They enrolled these 350 women with these implants, and they examined 120 gene variants and 14 different genes. So what did they find? Well, they found that BMI and duration of implant use was associated with this drug concentration in the serum. So we already know that a BMI over 25 reduces hormonal contraceptive efficacy. And the longer you have a hormonal implant, the less effective it becomes. So what they did find, though, that was unique to this study is that they found an association with this drug concentration in the serum with a particular genetic variant in a cytochrome P450 gene. This was a gene known as the CYP3A7, and this particular gene change is the CYP3A7 star 1C. So what is this gene change? What is this star 1C variant? Well, they found it in 5.1% of the population tested of these 350 women that were enrolled. And this particular gene results in expression of a fetal form of CYP3A7 that's not normally expressed in adults. About 30% of the carriers of this particular variant, so they only had one copy of this variant, either from their mother or their father, so they were a carrier. This 30% of those carriers had a reduction in the serum drug concentration. And this was a reduction that was at a level that would impact the reliability of the birth control. So at this particular serum concentration, these women may ovulate and the drug wouldn't be able to suppress ovulation, and thus they're at risk of becoming pregnant. And so the authors speculate that increased metabolism that's seen with this particular variant for this particular type of hormonal contraceptive may also apply to other steroid hormones and other contraceptives. So more studies will be needed to look into that. So in conclusion, the assumption that a lot of people have that women are always at fault when they become pregnant when they're using birth control may not actually be that accurate. While there may be women that become pregnant because of their own misuse of hormonal contraceptives, there actually may be a genetic component to failure. In that genetic changes in enzymes that break down hormonal birth control could increase the contraceptive failure risk. In particular, the study that I reviewed with you today showed that a fetal form of the CYP3A7 gene alone could account for about a 1.5% implant failure rate. So clinicians may want to consider adding genetic medication response testing as more data becomes available to help them to guide which type of contraceptives, whether they're hormonal contraceptives or maybe a non-hormonal form such as sterilization or a copper IUD, may be better for a patient. So I hope you learned a little bit today about pharmacogenetics and hormonal contraceptives and what the future may hold. And thank you for tuning in, and I will see you on our next episode.
Science education, feel this too. Molecular moms got it all for you.